I want to talk about trade-offs in modern architecture, but more so I want to talk about the design trade-offs. But before we get into that, I want to talk about a few things that will set the stage for what do we mean by modern architecture, first of all. Well, when it comes to developing applications, we often focus on functional requirements. And certainly, functional requirements are extremely important because we're building the applications so that it can provide the functionalities that our users want. And so as a result, our users often, or our business analysts, or the stakeholders often spend a lot of time and effort providing us all the business requirements. They're extremely keen on making sure we implement all those business requirements. But unfortunately, though, while we focus so much on the business requirements, and as programmers, this is one of the things that I'm sure every one of us, me included, spend our time on. We are focused on how do I implement this particular trade, or how do I implement this particular transaction, or how do I really transfer money from one account to another. All of those are, of course, business requirements we focus on. But as it turns out, we need to really think about what are called the non-functional requirements. Now, the word non-functional requirements is probably not a great term because for one reason, maybe the word non in front of functional may diminish the importance of it, which is quite the opposite of what we want in it. So what are these non-functional requirements? The non-functional requirements are a bit tricky because sometimes if you are very lucky, those non-functional requirements are stated explicitly in a requirements document. But oftentimes, non-functional requirements are either not stated, they are fairly understood or common in the domain that we don't explicitly state it, but we may forget while we are implementing, or it may be so obvious to the business, but we poor developers don't know about it. So we don't think about it in the beginning, and then we get caught off guard if it comes later. But the non-functional requirements are things that will have a very high impact. For example, when you are working with, let's say, student records, there are laws that are involved in student records. For example, I also teach part-time at the university, and there are not just recommendations, but laws that do not permit me to leave my computer turned on and walk away from my desk because somebody could access a student's record. I cannot provide details to somebody who calls and says, hey, I'm so-and-so, the student, can you give me information? The answer is no, I cannot, because I need to validate if that particular student is the one that is. Similarly, if you're dealing with medical records, there are laws related to privacy and so on. I have some clients who are in the medical industry. One of the things that they really hate the most is the regular audits they will get from FDA. And so there's a lot of requirements around traceability that becomes extremely important as well that you need to think about. Well, rather than calling them as non-functional requirements, I just mentioned the word traceability, so we can talk about them as what are called characteristics. So characteristics are extremely critical when it comes to developing applications. My good friends Neil Ford and Mark Richards wrote books on the architecture, the hard parts, and one of the things they emphasize is to create an architecture, not only do you focus on the business requirements, but you also have to think about these characteristics. Let's get down to a very simple analogy to understand what these things mean. Let's say you really want to open up a restaurant. So you decide, well, what would be really a successful restaurant? So we decide, okay, maybe I'm going to have really good food that's available. So you hire the best chef that's possible, and they know exactly how to make all these wonderful, food that you want to make. So you come up with a menu, you got your dosas and idlis and chutneys all, ready, right? So if you have the best chef and the best menu, you're going to have a successful business, isn't it? Well, as it turns out, your restaurant is in a very crowded area. People cannot get to the stall to order food. There is no convenient place for them to sit and eat. well, your business is going to suffer. So it doesn't matter. You can make the best food in the world. Your restaurant is not successful. Why? Because you cannot serve your customers properly. So if they cannot order food, or they're waiting for too long to order food, or you lose their order when they make the order, how do you survive such a business? Well, that's kind of where the non-functional requirements or characteristics come in. So when you are planning your business now, you say, of course, we need to have the best food and the best person to make the food, but we also need to make sure that we streamline the people who come and order food, make it available to them, make it convenient for them to sit and eat. So if you think about, Starbucks, right? Why do you go to Starbucks and pay such a high price? I go to Starbucks not because I want to order their coffee. Actually, this is the true fact. For years, I like to go to Starbucks because I love to work in a noisy environment. And the reason I like to work in a noisy environment is you're sitting there and you're so focused and there's a cloud of silence around you. I always tell people, it's perfectly okay for you to talk to me when I'm busy. Just don't expect me to listen to you. So essentially the idea is you're chatting all the time, and that gives me in that noise the space for me to work. In fact, it is so bad that anytime I would go to my brother's place or any of my relatives, and I really want to be left alone working, so I'll drop the family and I'll go to the Starbucks. That way I can just sit there and work, and nobody expects me to listen. And it turned out one day, when they were asking, where's Venkat? And the word is, he's working at Starbucks. Well, unfortunately, this did not get communicated properly. So my niece thought that I was a barista at Starbucks. So Uncle Venkat works at Starbucks, right? So anyway, it's good to have a job, I guess. But the point really is that in the case of Starbucks, one of the beautiful things about Starbucks is that workspace they provide. And what has that got to do with the coffee that you pay for, right? And that's a characteristics that draws business, and that's exactly what we want to think about. So when it comes to software, we want to think about a few ETs that you want to think about, or the characteristics that we often think about. So what are the characteristics that we may often think? Again, be careful. If you Google for the characteristics of architecture, you're going to find about 50 or 60 architectural characteristics. The worst way to approach developing software, you ask people which of those is important, and they tell you everything. That is really a disaster in the making. So one of the hardest things you have to do is to take the time to decide which of those is truly important. So you have to prioritize it, and which one is not as important or relevant to your application. So things we often talk about are like security, for example, or we can talk about scalability, if you will. You can talk about performance, for instance. You may even talk about things like accessibility, and so on. You could be listing portability maybe, or upgradability, if you will, and upgradability. And so on, and you can come up with all these ETs that you may think about, and these end up being the characteristics that you want to really focus on. But of course, who determines what these characteristics are? And the most important thing here is to let the business help us to arrive at these characteristics. If you try to convince the business that something is important, that could really work against you in the long run. So your job as a technical person is to first really work with the business to really help everyone understand and figure out what those characteristics are, and prioritize them based on what is really essential for the business. Now, one of the things that I want to really emphasize here is that when it comes to these characteristics, we can't have them all. That is one of the key things you want to really think about. For example, if you are thinking about scalability and performance for a minute. Now, this is one of the things I kind of take a little detour and emphasize it. This is something that has been taught to us very badly, I think. Maybe along the way, we took classes in the university or school, or maybe the first job we had, and they kind of, scared the daylights out of us saying performance is extremely important. The problem is we don't know what the word performance means, but it's extremely important even without knowing what it is. Anytime I show a functional style code, I cannot tell you how many times this happens. Every week I answer this question at least 4 times. Somebody would come to me and say, oh my gosh, you're writing code in a functional style, but what about performance? As in, this is going to be really slow, isn't it? So here is a question I would ask you. Let's say there are 2 cars I'm looking at, and they tell me one car, we'll call it as Model 1, so that we don't have to worry about any particular manufacturer. This can drive at a maximum speed of 200 kilometers an hour. And I have a second car, Model 2, let's say, and this can drive at 250 kilometers an hour. So here's a question to you. Which of those 2 cars do you think I should buy? What was that? What's the speed limit? No, those are the maximum speed it can go. So which one should I buy? So does the cost matter? I would first ask the question, where do you plan to drive it? If you say Bangalore, I would say you should get a bicycle, right? Not a car. The second thing, of course, is you said, what's the cost? Really good question. But another important question, how much gas does it burn? What if one is much more fuel efficient than the other? Or what if it's an electric car, which one gives you a better range? So these are things you need to think about as well. And in fact, as you kind of rightly pointed to, the fact that it can go at a higher speed is actually the least important, because you will never be able to drive at that speed in anywhere nearby. So what's the point in having a better speed? So one of the things we need to really think about is, so I always want to remind people about this. When it comes to performance, the question is not about speed. So we often think about this and say, hey, I want to know how fast can this run? It is not about speed. It is about, is it adequate? So I always want to ask the question, is the performance adequate? So it is the adequacy that you want to focus on. If the performance I get from a code is adequate, it serves my business needs, then why do I want to squeeze more performance over that? So maybe, just as a hypothetical, right? It doesn't mean this is true. Maybe your imperative style code is really fast, and maybe your functional style code is not as fast. Let's just assume that's the case. But if your performance needs are really here, did it matter that imperative style code would outperform functional style code, especially if the functional style code in that case is maybe easier to maintain than the imperative style code? So this is where we need to start really thinking about these trade-offs that we want to think about. So in a sense, I often say, if you worry about performance, the end result that you get is the worry and not the performance. And that is one of the things you want to keep in mind, is that we spend way too much effort worrying about things like performance, and when you're done with it, you're still worried about it, not that you got the performance. So as it turns out, there are times when you can get the speed, and there are times when you can get the scale. Now, I'm not by any stretch of imagination telling you that performance is not important, not at all. But it depends on what you're trying to do. I recently was asked to come and work with the team. And when I went over there, and they said, we are programming in C++. And I said, oh my gosh, is that true that every one of you program in C++? And everybody in the room nodded. And except for one lady in the middle of the room raised the hand and said, no, I don't. And I said, whoa, what do you do, lady? And she said, these boys program in C++. I write code in assembly. And I looked at her and said, thanks for doing it so the rest of us don't have to. And then I was kind of curious. This is 2024. Any Python in there? Nope. Any JavaScript? No. Java? No. C++ and assembly. And then, of course, I took the time to say, what do you guys do? And they said, we build missiles. I'm like, okay, that explains it, right? And so if you're building missiles, Performance is extremely important. You cannot say, let me take the time to blow up this other missile in the sky. So you want to really have performance. And so when you talk about performance, it takes you to a completely different level. When you're talking about a banking application versus a restaurant, a menu ordering application, and then these guys are sitting there and saying, we just fired a missile, I'm like, okay, that's a very different, game here in terms of what performance is. But it turns out that it is, so you can either get high scale or high performance, but not both. Now, I keep saying this, and a few weeks ago I said this, and there was a gentleman in my class, in my session, and he raised the hand. I said, yeah, and he said, that's not true. We do both. Our application has high performance and high scale. And I said, whoa, and how much do you spend on it? He said, a lot. So that is the key, right? So if you want a reasonable cost, you cannot achieve both scale and performance. You can spend millions to achieve that, and there are architectures that would support it, but you have to ask the question, what are your constraints you want to work with? So if your cost has to be reasonable, then you have to ask the question, do I want scale or do I want performance? Again, we'll come back to this a little bit later and see if you want both, and we'll talk about what that really means. So the idea really here is you want to think about these characteristics. But one of the challenges we often deal with is the following, and that is, if you spend a lot of time and effort providing what is not essential, you are going to have two problems. And I'll come back to these problems in just a minute, but just to emphasize it, this is an example of thinking about the CAP theorem. So the CAP theorem is a good reminder to really think about, so theorem is a good reminder about where these constraints come in. This is the theorem that's been proven. So this is not just an thought or an idea, it actually has been proven. And that is, what it says is, you can only provide, in general, two of the following three. That is, you can either provide consistency, or you can provide availability, or you can provide partition tolerance. So essentially, a partition tolerance, and you have to ask the question, which one you really want to provide. So you can provide two of them, but you cannot provide all the three of them. So let's say you really, really want to provide consistency and availability. Well, if you have partitioning of your network, you need to be able to deal with it, and it's not going to support it really well. So you need to really ask the question, which is really important. Now, Martin Fowler calls this as strict consistency versus, essentially, eventual consistency. Now, eventual consistency doesn't mean it happens in a few hours or few days. Like a flight I took a few weeks ago. I landed in Copenhagen, and I wanted to fly down to Stockholm, and after I landed in Stockholm, I got a notification what my gate is in the departure, airport. That is not eventual consistency. That's a broken system, right? So, but eventual consistency is very soon, within a matter of maybe, milliseconds, if you will, or fractions of second, things can happen. A strict consistency is where you're really making sure everything is in lockstep and consistent all the time. Now, the problem really is most businesses really do not need strict consistencies. Now, we as programmers somehow often get this in our head, and we tell ourselves it's got to be consistent all the time. Now, here is one thing I always ask my programmers, I plead with them, never, ever, ever go to your business and ask this question. Don't ask them, is consistency important? You messed with their life forever because now they got scared really. And now you're going down to the bathroom, they intercept you and they say, you're handling consistency, right? Because you scared them about this thing they didn't think about. And now they feel like somehow consistency is going to be compromised. Now, the problem in this case is if you enforce what is not needed, you cannot provide what else may be really essential. So that brings us to this problem I want to talk about. If you spend a lot of time and effort providing what is not essential, you got two problems. One is unnecessary complexity that you're going to build into the system. So your system is going to be more complex. So complexity in the system is going to be enormously painful to maintain because you're going to keep piling more things onto it that is needed. And more important, you may not be essentially be able to provide in this particular case what is truly essential. So this is where your business is going to be really unhappy with you eventually. It doesn't matter what you convince them to believe that's needed. When eventually you're putting in a production, it doesn't perform the way they want it to perform on that day. They're going to come after you and say, gosh, this is not really providing, you don't have good availability, what's up with that? And you said, but we can't do it because you wanted consistency. They're like, we didn't want consistency. You are the one who actually told us it's important. So you're not done justice to your business by doing so. So essentially, you always want to make sure that you never work hard to provide what is not essential, because for every path you take, there are paths you cannot take. That is one of the things that scares me the most, because it's not the choice you made, it's the things that you did not take that you could have otherwise taken. So you need to really understand what your priorities are. So this is where the trade-offs really come in. So we have to think about the trade-offs. And if we don't evaluate the trade-offs, then we are driving based on emotions, infatuation, misinformation, and the result is actually a disaster waiting to happen. And so what can we do about it? Now, this is also one other thing you have to be careful about. As a person working on a team, you are responsible to make decisions. But here is the sad part of the lives we live in. You can work on a project, and maybe it is taking a while for this to be implemented. You might make these decisions, but you might quit before the system actually goes into full production. But the problem is you are leaving behind something for others to really deal with. This is another thing I see a lot when I go to my clients. I was recently in London, and we were looking at a piece of code, and we came across a particular design decision the team had made. And I'm not kidding with you. That one decision the team had made, for us to move forward, we got to make code changes. And the manager of the team was red-faced, sitting there staring at me and saying, we thought we can pick up this idea, get this implemented next week. Now, from what we learned right now, it looks like we need to make 6 months of change for this to work. And I'm like, sorry, what can I do? The decision that you guys made is making it harder for us to change. That's going to take you 6 months. And he was like scratching his head. I turned my head to the architect who was sitting next to me, and I leaned over to him and said, why did you guys make that design decision? And he gave an answer that everybody that I've ever interacted with readily give me. And he immediately said, Venkat, you should know that was done before I joined the company, right? So this is the case. And I immediately tweeted, and I said, technical debt is the gift you give for the future developers, right? So somebody made this decision and they're no longer in the company. They've gone. And now you have inherited. You're not the programmer in the team. You're not the architect in the team. You are the victim. Because now you have to maintain that code, and you're sitting with something that's going to take you 6 months to change. So the decisions we make have consequences, and we got to ask the question, did we just take a shortcut? This is one of the things we need to ask. When somebody says, I've got a great idea, I'm like, usually, what's the catch? I want to know what the consequences are because that could come back and backfire. It can be really a time sink in the future. We got to know what that means in this context. So the question here really is, we want to be able to evaluate these trade-offs. But we'll come back a little bit more to it as we go on. But let's talk about modern architectures just for a few minutes. Now, I have to say that we work in an industry, we really have trouble naming things. And think about a lot of names that don't really communicate the essence. Think about a terrible name in the industry. I can think of NoSQL, like why? NoSQL actually has SQL. So why do we want to call it NoSQL? And we struggle with this, like wireless network. Why are you saying less of something, right? Or you say cordless and the kids freak out. What's a cord? They don't know what a cord is these days, but it's less of it. So the point is we struggle to give names to things. One such example is this idea of monoliths versus distributed systems. And the unfortunate part is this, and that is monoliths are, I want to emphasize, are distributed. So in fact, I want you to think about this. When was the last time you ever implemented a monolith that was just one big blob and had nothing else? That was about 40 years ago. Nobody has ever built anything in the past 40 years that is just one thing. You have a database server. You have an application server. You have a server to process your financial data. You have all of these distributed. So almost every single system is a distributed system. So when we give names like this, the problem with naming is you may understand the difference for a while, but it gets lost in translation. The more we keep using the word monolith versus distributed, it etches in your mind, maybe then monoliths are not distributed. Then why are you not using the word distributed? This is where it gets a bit confusing. So monoliths are distributed. So then what is the difference, you could say, between, a monolith on one hand, and maybe a distributed architecture? So the answer to this question really is, it is not about deploying, it's not about the runtime, right? So it's not about the runtime. It is really about the unit of deployment that you are really talking about. So in other words, monoliths, essentially when it comes to monoliths need or require, you can say, a single or synchronized, you could say, a unit of deployment. So essentially, I will openly tell you this. I have monoliths in production. And this is one of the problems we deal with in the industry. We feel like we have to do things because everybody else is doing. Maybe you're in the conference, you're sitting down and having lunch, and everybody is asking you, what are you doing? And everybody around you says they're building monoliths because everybody should be building monoliths, right? And then you blurt out, I'm building everybody says I'm building a microservice. So everybody is building a microservice, and then you blurt out, you build a monolith. And suddenly everybody switches to another table, right? Nobody wants to sit next to you anymore. But that is the problem, is we have this infatuation, and somehow we feel like there's one way to do things. Well, but a monolith, I will tell you, I've got monoliths in production. And I will also tell you, I have no desire to change them into a microservice. And you say, why? Because very simple, it serves my business. And when it serves my business, I don't need to be infatuated. I don't need to be worried about calling it something else. But then you say, is there anything I do not like about my beautiful monolith? And there's only one thing that bothers me. I've got multiple instances of it running, but when I have to upgrade it, I've got to upgrade them in a certain sequence because the deployability is a single unit of deployment. So if you're ignoring the deployability for a minute, well, there could be benefits to simply using monoliths versus microservices, at least in that narrow definition of things. So the idea here is, pardon me, a monolith needs a single or synchronized unit of deployment. On the other hand, a distributed, you could say, architecture, On the other hand, facilitates is probably what you want to say. Facilitates, you could say, distributed or multiple units of deployment. So this is one of the benefits you get out of being in a distributed system. It's not the execution model, it's a deployment model that we talk about. And of course, this also leads to different characteristics. So you can think of a monolithic architecture. A pipelined architecture is also a monolithic architecture because oftentimes these different parts are all dependent on a certain code or a certain data structure. And if you modify them, you got to synchronize the deployment of all of them. So that becomes your constraint. So is a microkernel architecture as well. A microkernel is also a monolithic architecture. However, you could go towards more of a distributed architecture when you look at a service-based versus a microservice architecture. Now, when it comes to the service-based or microservice architecture, you are really enjoying this ability to have multiple units of deployment. However, on the scale, not only do you have more flexibility when you go top to the bottom, you're also increasing the cost and complexity as well. That again becomes the trade-off. So you have to ask the question, what do you gain, what do you lose? So on one hand, you have simplicity. So on the other hand, all the way out, you have complexity on the other side. So if you really say, hey, I really want simplicity. On one hand, it is less, you could say, expensive. On the other hand, you can say it is very costly. So if you think about it, you need to really think about these trade-offs. And I'm sure we can list more things here as well. So what do people do today? You talk to almost anybody. If everybody wakes up in the morning and say, we are building microservices, how could that be actually correct? Because if everybody says, that's what we should be doing. And this is, like I said, infatuation. It's very dangerous. I was giving a talk in a conference in Poland, and I mentioned during my talk that 80% of people who say they are building microservices, I would say, microservices are really not building one. And I mentioned this during my talk, and somebody immediately tweeted that. It said, oh, Venkat says 80% of the people who are building microservices are really not building microservices. And somebody replied to the tweet and said, well, he's wrong. That number is 90%. So the point really is, we're living in this world of infatuation that everybody wants to build microservices. I was in Austin, and a lady came to me and said, hey, we're building microservices. She was definitely proud about it. And I said, oh, that's great. That's awesome. And she said, everything is great, except we have one problem. I said, that's pretty darn good. If you have only one problem, that's awesome, isn't it? And then I was curious, what is that one problem? And then she said, if one microservices fails, everything fails. And I said, have you considered maybe you're not building microservices? Here in Bangalore, I have a client, and I was talking to them about this, and I said the misconception. And one of the developers said, okay, Venkat, let me explain to you what we do. This is a fintech company. And he said, let me explain to you what we do, and maybe you can give a name for it. I said, I'm ready, go for it. So he takes time to explain the architecture of his system. And then after he finishes, he says, now what do you think we are doing? And then I said, well, based on the description you gave, you are building an enterprise application which uses web services. And then there's a long pause. And then he says, so you are saying we are building enterprise application with web services. I said, that's exactly what I said. And then he said, but can I still say that I'm building microservices, right? That real desire, because I got to say I'm building how could I go to mom and dad and say, what are you doing? Oh my gosh, look at the neighbor's kid. They are building microservices. You should grow up, right? This is peer pressure. We have to build microservices for some reason. We don't know what it is, but we are building it. And worse code has been written in the name of doing this. And here is again the problem with naming things. I really want to say I don't like this name. And the reason I don't like it is, microservices are neither micro nor services. That is the problem I have with that. It is neither micro nor services. Now, here's the reason I don't like this term. There is a lot of misconception around it. I was in a meeting a couple of months ago, and suddenly a developer randomly blurted out these words. We're in a meeting, and suddenly he said, oh, by the way, that is too big to be a microservice. Like, whoa, wait a minute. What did you say? Oh, that's too big to be a microservice. And I'm like, wait, do you actually take it and put it on the scale? Oh, this is 2 kilograms more. That's what they do when they come in the airplane, right? You can't take this bag in, it's 2 kilograms more. This is a weighing microservices, right? Put that on the scale. Sorry, that's not a microservice, it's too big. And this is a misconception we have. And somebody told me, oh, if it's a microservice, it should be built by people, a small team. And you need to have a team of 2 pizza teams. I don't know about you. Never challenge a person how much pizza they can eat based on their size. I'm a really small guy, but you should never challenge me. I can eat more pizza. You get maybe quarter of me if you want a 2 pizza team. So the point really is, again, a misconception as to what these things mean. So here is my definition of microservices. Now, if you think about it, think about this for a minute. If you say, hey, I have a microscope. Now, would you need a lens to find where my microscope is? You come in and say, you said you have a microscope. Here's a lens. Where is your microscope? I want to find it. Well, microscopes are fairly big, isn't it? They are of different size depending on what you're looking at. So I'm going to say, this is my definition of what I feel it is. I'm going to say microservices. So the micro in microservices, if you will. So the micro in microservices is like micro in a microscope. So a microscope is actually fairly big. What is small is what it is looking into. So this is exactly what we are focused on in here. A microservice is focused on the domain, with a bounded context. So when you talk about micro, the micro is not the code. The micro is the scope within the domain that you really need to be focusing on, which is what you really, really need to be thinking about. So my microservice really is, it's the focus into what I am building, not the code base or the size or the binary or the source code or the team size. So essentially, if we rethink about what we are building, if we understand, we tend to really think about it very differently. So I can have a microservice as big or as small as I want, as long as we define what the bounded context is, which again brings the question. I was in Dallas, and a developer a team leader came to me and said, we're building microservices, and it's a disaster. And he works for a large financial company. And I looked at him and said, you said we are building microservices, and it's a disaster. And he said, yeah, that's what I said. And I said, who is we? And he said, what do you mean, who is we? I said, we are building, which means it's my team. And I said, yeah, I get it. But who is we in your team? Well, I'm a team lead, and I have programmers with me, and we are building it. And I said, that's a problem. You guys are building it, but you never invited your business to the party. Because if the business is not involved in building your microservices, how do you understand the domain and the bounded context? So we need to really rethink about what we build. So these constraints have to come from the business. So we cannot simply get together and start building it and then complain that it's not working for the business. So the question you want to really ask here is about these characteristics. Now, when it comes to this, why do we want to build microservices in the first place? That is something I want to think about. I'm not exaggerating right now. I really wish this is a joke I'm telling you. It would be funny if this was not true, but this is really true. I cannot say the company's name here, but it's a very large insurance business in the US. I was working with them, and I asked a question to the developer, and I really wish the developer had said no to me. But I asked him, hey, I'm looking at this class here in the code. Can I take a look at the database for this, please? And unfortunately, he said, sure. And he opened up the database and he showed me. And I was in panic because for this class, the table that he showed me in the database had 800 columns. And I looked at this and said, oh my gosh, it's got 800 columns. He had no emotions. He said, uh-huh. And then I said, wait, you have thousands of tables, and every table has hundreds and hundreds of columns in it. Uh-huh. I'm like, whoa, why? And he said, because they need it. And I said, who is they? And he said, Venkat, you got to understand, we're an enterprise. We got thousands of applications, and the thousands of applications are using that database. Now, I want you to think about this for a minute. What did we just end up with in this case? This is called unified data model. So this is a unified, so this is called a unified data model. Now, when you have a unified data model, what is going to happen in this case? So just play the scenario out for a minute. You got this schema, and the schema contains all the tables and all the columns, and you can think about it. Now, you are sitting here and doing work, and you realize you need to make a change to this particular schema. Now, what's going to happen if you make a change to the schema? You make a change to the schema and you push it, you just brought down the entire enterprise, isn't it? Because your change is going to affect everybody. You probably know this already, right? Maybe you're interviewing with a company, you're having a great time with them. They tell you, let's go to the cafeteria, have some food, and then continue the interview. You're going to the cafeteria, you're seeing that people are just having a great time eating food together. And you're just curious, you want to know, what would it feel like to work in this company? You look at one table, they are talking about politics. In the other table, it's even worse. They're talking about JavaScript frameworks. And you're like, wow, this is an interesting place. And then you look around, and way back in the back of the room, there is one person alone, away from everybody else, facing the wall and eating alone. And you say, who's that person? And they say, we don't talk about this person. You say, what happened? And they say, he tried to change the schema 3 weeks ago, and he's on a timeout, right? So when you walk into the company, what do they tell you? They will tell you one thing, right? The message when you enter the building, they say, don't screw up. That's what they're going to tell you. Because if you modify, so what is on their mind? Stability, right? Stability is more important than agility. Now, in the meantime, guess what's going to happen? Your business comes to you and says, hey, we have a change in the tax law. We want to recompute the tax differently and apply this surcharge. We need to make this change. And your developers are like, no problem, right? Because we never say no, right? No problem. So they're like, good. When can I have it? It'll be done. No. When can I have it? Maybe 8 months. What, 8 months? Well, you don't understand software development, do you? Because we need to write a change request. We got to define the changes we're going to take to the schema. We got to send it to the architecture committee. They will take the time to review it. Then they will approve the change. Then we will design the change across all the teams. We'll do an impact analysis. We got to ask this team how much time you need to make this change. They need to tell me. When everybody is done, we can make this change. So what did we lose in this case? We totally lost agility. But you say, aha, but notice what we did. We have very high reuse. We have dry, but we have low agility. Now, you say, wait. You have high reuse and high dry. Well, guess what? As developers, it's been hit on our head. Write reusable code. My gosh, follow the dry principle. How dare you duplicated it? And in fact, we can convince ourselves by using the right words. The term you will use here is, it's a single source of truth. It's not a single source of truth. it's a single source of disaster because everything is in one place. So we can convince ourselves by saying, oh, it's a single source of truth. Isn't that a good thing? It's dry. Isn't it a good thing? It's reusable. Isn't it a good thing? Yes, it's a good thing for us. In the meantime, the business is scratching their head. Why can't I? That's what happens, right? So they are like screaming over there. Why can't we have the change when we need it? And we tell them, you don't understand software development. We have dry, we got reuse, we are efficient. And they're like, what does efficiency mean when we cannot get our business done? But fundamentally, we did not even think about one thing in this particular case. Now, what is that? If I am writing a class, and in my class, I made my field public, what would you tell me? You'd be screaming through your lungs, isn't it? You would say, oh my gosh, I don't know who hired Venkat. He makes all the fields public. Why shouldn't you make the fields public? Because it's poor encapsulation, isn't it? Now, what did we just achieve here? You have the schema which is shared by all the applications. One application changes the schema and every other application breaks. So what happened in this particular case? So a shared, you can say a shared database is equal to poor encapsulation. And as a result, low agility. I'm putting 3 equals just in case there are JavaScript programmers in the room. So essentially, you are looking at where you have a shared database, but you just jeopardize encapsulation, period. So if I modify my schema, your database format is exposed to all the applications. What is that called? No encapsulation, which is the funny part. We keep using this, and we don't even realize we completely broke encapsulation. On the other hand, you just make one field public, we scream. But this is even more extreme compared to that which is more localized within your code. So the key here is, now all of a sudden you realize there is a huge design trade-off. You can have low encapsulation, low agility, but you can have more reuse and more dry. Or you say, maybe I want to rethink about this trade-off here. So if I were to, let's say, more coupling, provides more reuse. But if I ask you, should I have high coupling or low coupling? You're going to say low coupling. But if I ask you, do you want more reuse or less reuse? You want more reuse. But that's a contradiction. You cannot have both, right? It's like when my when my son was very small, my wife used to trick him for a while. He would want to watch TV, but he's got to sleep. So she would tell him, sweetie, close your eyes and watch TV. And the kid would do that for a while. And she's like, I got him, didn't I? He'll close his eyes and he thinks it's, and then one day he said, Mom, how do I watch TV if I close my eyes? Oh, we can't use the trick anymore, right? But that is what we've been doing to ourselves, is we don't think through these consequences. We are like, oh, I want more reuse. Do you want coupling? Oh, I want less coupling. But by definition, if you're reusing something, you need to couple to it. So you're increasing the coupling. So you cannot have one without jeopardizing the other. So essentially where this really turns out to be is, don't think of these as switches. You're not turning on a switch and walking away. These are dials. And if you turn this dial, something else is going to turn over here. And what you're asking here is not which one can I have. What you're asking is, what is the range I can have so that I can meet them within the range? So you cannot have this extensively because you lost the other one. You cannot have the other one extensively because you lost this. And now you got to forcefully bring a trade-off into the picture. So on one hand, you're looking at coupling. On the other hand, you're looking at the reuse and also encapsulation. So one of the things I often tell people is this. If you're building microservices, again, you have to evaluate these. Don't take these as mantras and blindly follow them. But I think these can be the first steps to think about. I often say this. There are 2 things I would never share with others. This is just my principle. The first is a toothbrush. I'm not going to share that with anybody. That's my toothbrush. I use it. The second is a database. Very rarely, I may even share a toothbrush with a very close family member, but never a database. So my mantra here is, do not expose your database. Instead, export your data. Again, you want to really evaluate these, but that would be my recommendation. But why is that? Because you're providing better encapsulation and agility if you export the data rather than exposing your database. But of course, there's a trade-off. I can go directly and get data from your database. Now I have to make a call through an API and get the data. So there's a network call. Yes, sure, database also had network call. But this is through an application layer, you have to get to the data, which means your overhead is higher this time. But you're, again, compromising. You're saying, I am willing to take this extra overhead because I really want agility. Why? Because that's what my business cares about. And so the business doesn't need that much performance. Why? Adequacy. Again, adequacy is important. When you are in a meeting, don't ask the question, well, that's going to be slow, right? That's a very misleading conversation. Don't assume it's going to be slow. Don't assume it's going to be fast. Instead, ask the question, what are your expectations in terms of performance? What do you want? And then work your way to find out, can you bring agility the business needs? Oh, by the way, let me emphasize this. This scares me, but this is the truth. I was traveling to a client deep down in Massachusetts, down south of the state, and I was talking about agility, how we need to really be agile, and how we want to respond to change. And their director raised the hand and said, I don't understand what you're saying. And I said, don't you want to make changes and respond to your business needs? And he said, listen, we're in a highly regulated industry. Our clients want to change once in 15 years. If I change any sooner, they get angry at me. And I said, seriously, your change doesn't happen once more than 15 years. He's like, I don't have a clue what you're talking about, fast and agile. We're sitting here and nobody wants our change. They will refuse to accept any change. We change every 15 years. I said, you don't need any of these things. Just be happy and don't change anything. So don't force on. I mean, that's a very odd situation. I couldn't sleep that night thinking there's businesses like that, right? But if that is their business, who am I to tell them, you got to have change. You got to embrace change. They're like, embrace what change? There is no change once every 15 years. And if the business doesn't have a need to change, don't force fit into them. But if your business says, hey, we want to be able to change things fast, then ask the question, how can we achieve that change? How can we provide that business agility while compromising other things, but not to the level where it's unacceptable? So what is the range of performance that you can provide to the reasonable expectation? What's the range of scale can you provide? What's a range of evolvability can you provide? All of these. So the best way to fail at anything, say the word fail, it fails. So the best way to fail at anything is to be absolute in your terms. You should never say, I want that scale, I want that performance, because it's a single point, you cannot attain it. Instead, talk about the range that is reasonable from the business point of view. We want a performance within this range. We want scalability within this range. How can we design things to come within both of those ranges so we can compromise and still provide a solution? That's what you want to really focus on. So essentially, what you want to evaluate here is work your way from the business. So start with what the business really needs, not the want, but needs. You need to really sit down and ask the question, what do you need from the business point of view? If I haven't understood the business, How can I deliver solutions for them? And if your business is saying, these are the things we want, but also keep in mind, sometimes it's very, very reasonable. Maybe a lot of times it's very reasonable for the business to say, we don't know. They may not say in those words, but it's your responsibility to work with them so you can extract those details from them rather than feeding those details into their head. I cannot tell you how many times I work with teams where they have a solution in their mind and they're convincing the business that's a solution you need in so many different words. Instead, just drop your ideas of how you implement things. Take the time to understand what the business really is focused on, what their true needs are, and engage in a conversation. Don't go to them and say, hey, consistency is important, right? That doesn't help them. You instead ask the question, hey, I've got a question for you. Joe is performing a transaction here. His wife, Sarah, is performing a transaction here. They both are depositing money and withdrawing money. How do we handle it? At one point, I was a very, very poor graduate student. As a graduate student, you don't have money, but you got time and you got the power to think. So I spent my youth trying to understand how banks worked back in time. And I figured out banks would apply all the deposits first, and then they will apply all the withdrawals after. Because if you reject a particular transaction, that is expensive to the bank as well. They got to do more paperwork. This was great when you don't have money, because I can wait for a deposit to clear and go back and withdraw money on the same day without worry about, they going in the out of order. And the point is, that's a discussion you want to have with the business and genuinely ask the question, how does this work? And I want to know how these things work. Now, when you build these characteristics, what's going to happen? And if the business tells you that we need, conflicting characteristics. So maybe this happens, right? So the business says, I want performance and I want scale. And you're scratching your head. Well, at what cost can I provide it? And they tell you, this is what we want to spend. We don't want to spend millions of dollars on it. Well, don't take that as a way to say, my gosh, that's what I have to provide. Work closely with the business and ask them, yeah, that's great. You said you need both, but can we drill down a little bit? And then you realize there are certain operations that require scale, and there are certain other operations that require performance. And now you say, aha, that's perfectly fine. We can divide this into microservices, another reason to do so. And this set of microservices will give you the scale. Maybe these set of microservices will give you performance, or even a monolith, nothing wrong with it. So you can have some microservices and monoliths. So that is another reason to divide your architecture into different models, because your characteristics are different for different parts of your system. So this gives you an opportunity to rethink about your architecture based on the trade-offs. So your architecture needs to facilitate the trade-offs that come from the business. Your architecture is not about your desire. Your architecture is not about your infatuation. Your architecture is to say, here is the business, and here are the characteristics, here are the expectations from the characteristics, here are the architectures that can provide the trade-off. Now, of course, you can do all of this, but eventually those characteristics would end up changing. And if those characteristics were to change, you need to reevaluate your architecture and provide the change, because it's not static, where you do it once and you're done and you got to reevaluate it. So this also requires documenting things properly so we can provide that as well. So essentially, the trade-offs are probably the most important things to evaluate when it comes to architecture. So I'll conclude by saying architecting is an act of evaluating trade-offs, and the more you do a good job with it, is a better architecture you will arrive at. Hope that was useful. Thank you.